Let's now move on to a new topic called operator precedence. Consider the following expression. Result is equal to 2 plus 3 times 4. In what order is this expression evaluated? There are obviously two ways to evaluate this expression. We could first do the addition, so we could say 2 plus 3 to get 5, and then multiply 5 with 4 to get 20. The other way to evaluate this is to first do the multiplication, so 3 times 4, 12, and add 2 to it to get 14. And it turns out the compiler does the second evaluation. So it will first evaluate 3 times 4 and then add 2 to it to get a result of 14. And this is due to what's called operator precedence rules. The rule of thumb is the following. Operators with higher precedence are evaluated before those with lower precedence. It turns out that multiplication has a higher precedence than the addition operator. So the compiler will always evaluate the part of the expression where the operator have the higher precedence. Because the multiplication has a higher precedence than addition, this expression is equivalent to, in a sense, 2 plus parentheses 3 times 4. Um, you're recommended to write it like this rather than write as shown at the top, because this is from the user's perspective, who doesn't know which operator has a higher precedence. The user might not be able to figure that out. But if you write it explicitly with parentheses, as shown at the bottom, it is very clear. To the compiler, it doesn't matter. The compiler knows the precedence rule, so even if you write the expression as shown above, the compiler will be able to evaluate it correctly. But it is recommended that you make it explicit by using parentheses. The next topic is operator associativity. Consider the following expression. Result is equal to 10 minus 3 minus 1. In what order is this expression evaluated? Again, there are two ways to evaluate this expression. We could first do the first subtraction, subtract 3 from 10 to get 7, then subtract 1 from it to get 6. Or we could first evaluate the second subtractions to get, to subtract 1 from 3 to get 2, then subtract 2 from 10 to get 8. So there are again two ways to to evaluate this expression, and it turns out the compiler will choose the first one this time. So it will first subtract 3 from 10 to get 7, and then subtract 1 from 7 to get 6. This is due to operator associativity rules. Operators with the same precedence, as you can see, all operators in here have the same precedence. They are all minus operators. Operators with the same precedence are evaluated based on their associativity rules. Because subtraction is left associative, the evaluation goes from left to right. So this statement at the top is equivalent to, if you parenthesize it, to the one shown at the bottom, meaning that we will first be doing the subtraction of 3 from 10. So that's the first expression will be part of the expression that we'll be evaluating. Then we'll take that result and subtract 1 from it to get the final result. Here is a table showing the precedence and associativity rules for most of the operators in C++. At the top, you see the parentheses. Then you see unary increment and unary decrement. Then unary minus and plus. Finally, next on the precedence list is the multiplication, the division, and the modulo operator. Then you have binary plus and minus, right? So the addition and subtraction. Then the assignment operators, and at the bottom of the hierarchy, the precedence list, is the comma operator. We'll see that later on. And look, if you look at the associativity rules, most operators are left to right associative except for assignment. It makes sense that the assignment is right to left associative because we already showed this. You might have A equal to B equal to C equal to D. So it makes sense that the evaluation starts when you have these multiple assignment operators. That the assignment starts right at the right end of the expression and then go towards left. So that's why it is right to left associative. But otherwise, most of these operators are left to right associative. It is difficult to remember all the precedence and associativity rules. So it is best to parenthesize the expression to avoid ambiguity. To the compiler, parentheses do not mean anything. The compiler knows how to evaluate the expression based on the precedence and associativity rules, but usually it's a good practice to parenthesize your expression to make it explicit to programmers when they look at your. Let's now look at some expression examples and how they are evaluated. So here's one example. A is equal to 10, B is equal to 20. Result is equal to A plus B times 3. Let's apply the precedence and associativity rules. So the multiplication has a higher precedence than addition. So we would first be doing B times 3. So 22 times 3, it's 66. Then do the addition, which is 10. 66 plus 10, that would be 76. And you would get A10, B22, result 76. The next one is result is equal to A plus B times 3. This time A and A plus B is parenthesized. That has a higher precedence than the multiplication. So we would first be doing A plus B. So 10 plus 22, that would be 32 times 3, that would be 96. So as you can see, as soon as we parenthesize the expression, we are making it explicit that we would like the compiler to evaluate this part first, then do the multiplication. Another example, A is equal to 7, B is equal to 9, C is equal to 4. The expression is result is equal to A plus 10 modulo B divided by C. So obviously, we will first do the part of the expression that's parenthesized. So A plus 10 is evaluated first. So you get 17. Then the expression is evaluated from left to right because both of these operators have the same precedence. So associativity rules take over. That means we'll first be doing 17 modulo B. B is 9. 17 modulo 9 would be 8. So this part is now 8. And 8 divided by C, which is 4, is 2. So the result would be 2. And A, B, and C will not change. In this example, we have A plus D modulo B divided by C. So we parenthesize the expression, the right-hand side of the expression at least, to first ask the compiler to compute B over C before taking the modulo operator. So this time we first do A plus 10, which is 17, then do evaluate B over C because this is parenthesized. So B over C, 9 over 4, both of them are integers as you can see. So this will do integer division. 9 over 4, when you do integer division, is 2. So you've got 17 modulo 2, that would be 1. All right, so that's the result of your expression. Let's move on. This A is equal to 7, B is equal to A, 8. And now I am saying A is equal to multiply equal to B plus 1. The way to evaluate this is first evaluate the right-hand side of the equation. So B plus 1 is evaluated first. So it becomes, this is B plus 1 is 9. Then we take 9 and multiply it with A and store the result in A. A is 7. So 9 times 7 is 63. So the value of A would be 63. So before the evaluation, it is 7. But A after the evaluation is 63. And B is still 8. Another assignment operator. So we are saying A is equal to B is equal to C is equal to 1. Obviously, all of these values would be 1. Now look at this interesting expression. It says A plus equal to B plus is equal to C. Remember, when you have assignment operators, the assignment operators are evaluated right to left because it has right to left associativity. So this part will be evaluated first. B plus is equal to C will be evaluated first. So you've got B is equal to 1, C is equal to 1. So when we evaluate B plus is equal to C, B will now be 2. And that would be the result of this equation. And we'll be taking 2 and adding it to A because it's A plus is equal to 2 now. So A would be incremented by 2 and will be 3. So after the expression is evaluated, C will still be 1, B will be 2, and A will be 3. And that's right in here. Moving on, A is equal to 10, B is equal to 5. We have plus plus A plus 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 B. So both of the unary increment operators come before the variable. That means they will be evaluated first. and then the expression will be evaluated. So we'll be taking A, incrementing it by 1, so it's 11, plus we'll be taking the current value of B, incrementing it by 1, that's 6. So this is like saying 11 plus 6, so the result is 17, as you can see. So the result is 17. Let's look at this one now. So here, A is A plus 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 B. So this time, the current value of A will be taken, so it's 10, and then A will be incremented after the expression is evaluated. So the final value of A will still be 11, but the value of A that we use in this expression is 10 because plus plus unary increment comes after A. But the unary increment is still in front of B. That means we'll be incrementing B, which would be 6, and then adding it to 10. So result will be 16 this time. Moving on, we have this expression where plus plus A times B minus minus plus minus minus C times A. So we already actually evaluated this in the previous slide as far as I remember, but let's do it again. So plus plus A, it would be 6 times B minus minus, so it's 2. 6 times 2 is 12, right? Plus minus minus C, so it would be 7. And we are now using the current value of A, which is 6, as you can see, because we already incremented it. So it's 6 times 7, 42. 42 times 42 plus 12, that would be 54. And that's the end of it. Before we finish our discussion on operators, I should mention that C++ has 6 bitwise operators that operate on integer types at the bit level. So here are the symbols. This is bitwise AND, this is bitwise OR, this is bitwise XOR, this is bitwise NOT, this is left shift, and this is right shift operator. Each of these operators operate on a bit by bit level. I don't want to go into the details of this because we will not be making use of these operators in this class. I'm just providing it for completeness sake. Bitwise operators are often used in low-level programming, graphics programming, and embedded systems. So it's mostly systems programming where you're going to see these bitwise operators being used. Just as a note, care should be taken when using right shift with signed numbers to avoid unexpected behavior. Again, understanding bitwise operators is essential for certain programming tasks, such as working with hardware, networking, embedded programming, or optimization. But for the sake of an introductory programming language course like this one, we will not be using them. I'm just providing them for completeness sake, for the sake of completeness.